Hello, it's Ben Robertson here. It is Science, Mr. Robertson. It's a video from me and it's a crazy and ambitious one because I have a full periodic table behind me on the board. I want to just point out a few things that you can know and we'll use some of our atom knowledge from the classroom. Firstly, I know I've mentioned before about the metals over this side on the left and the non-metals on the right. That line is actually down here. So I can go and things like boron, silicon, arsenic. They're the metalloids. They're the things that we don't know if they're metals or not. They're sometimes metals, sometimes not metals. But all the metals are over here. Things like iron, things like titanium. So we've got all of these here, and we've got all of these on the other side. These are, of course, the non-metals. Oxygen, fluorine, neon in a chain all there, for example. Most of them over there are gases. Most of these are solids. Mercury here, quicksilver is a liquid, as is bromine at room temperature. Of course, all of these can be a liquid if they get really, 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 really hot. But otherwise, at normal room temperature, this here is true. Now, there are some patterns you need to know about. For example, we have over here what we call group 18, or you might also see called group 8. It's 8 because in the outside shell of all of these electrons, well, it's full. Helium is weird. It's in the first, it only has 2 in the outside, but then it's 8 on the outside, 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 8 on the outside. They all have 8 electrons on the outside. Their outside electron shell is full. Those atoms, they're really happy. They don't want to bond or react with anything. So you never see helium in anything else other than by itself. It can't share electrons, it can't take electrons to anybody else. The same with neon. It doesn't do anything to anybody. They are what we say here, I'll do it a little bit higher, unreactive. They do nothing. Compare that to the ones just next to them. Fluorine, chlorine, bromine, iodine, acetine, all of these here. Group 17, or again, group 7. Because, they all have 7 electrons in their outside shell. And that's not good. They're so close. They're so close to having 1 more electron for a full shell. These here are very reactive. Very, very, very reactive. On the other side, these ones here in group 1, so that's 1 because on the outside they have 1 electron. Hydrogen, lithium, sodium, potassium, these are also here as well. Very reactive. They want to give away their electrons super fast. And if none of these are sharing, hey, that lithium is going in there and it's giving away its electron as fast as it can. But let's pretend, for example, let's take fluorine here. And there's 1 fluorine atom in the room. We also have 1 lithium and 1 sodium. A lithium or a sodium. Now that fluorine, hey, that can choose which of the metals is going to be the boyfriend. Which one is it going to accept the gift of an electron from and then be with until a better one comes. here's where we need to think about the atoms. Lithium has a structure of 2, 1. 2 shells, 2 electrons, 1 electron on the outside. Sodium is 2, 8, 1. Has an extra electron shell there. What I can see with this is that this electron is closer to the middle. If it's closer to the middle, it's closer to the positive nucleus. Positive and negative, they come together anyway. We know that. And if you're closer to the positive nucleus, hey, you know what? You're going to be at home just a little more. You only a little bit want to get away. But that sodium, that electron, that's miles away. And it's so much easier for fluorine to go and find sodium. So it's the sodium here that would take the place, and the sodium would react with the fluorine. And it's the same the whole way down. Potassium is actually going to be here, 2, 8, 8, 1. The electron is further away, so it's easier for fluorine to take it. So potassium and fluorine would take the place. Rubidium would come in and would win over potassium. It works the opposite the other way around. Let's take potassium. Let's say potassium is the one we have, that is the winner. Potassium there has to choose if it's going to have fluorine, which is 2, 7, or chlorine, 2, 8, 7. Remember, the closer to the nucleus, the closer to the positive centre. If I take this one electron and I put it in here, that's good. They're bonded, they're happy. But if I go to the fluorine, then the fluorine is the one instead. The fluorine is going to be the most reactive. It's the complete opposite. It's closer to the nucleus, so it's going to be more attracted, more reactive. So you can do it here. These, as they go down here, they get to be most reactive in group 1. And here, it's the opposite. It's going up is the most reactive. And that's all from using our knowledge of the different atomic structures. We can also say with this that a pattern is that as you come down the periodic table, the atoms are getting bigger. There's more protons. Every new number means a different atom, so a different number of protons. And that means also many, many, many more neutrons. Protons and neutrons make mass. And yeah, bigger atoms need a little more space, but not too much. Because all of that mass, the protons and the neutrons, is in the middle. In the nucleus. The atom kärnan. So what we can also say is that magic word, the density, we've studied that before. As I go down the periodic table, it increases. The further down the periodic table, the bigger the density. The bigger those atoms are. At the very bottom are all of these atoms which are, well, almost imaginary. They don't really exist in nature because they're so big, they're unstable. You can't keep that many plus atoms together It's like holding a big sandcastle. It's just going to collapse. And that's what happens. And when atoms collapse, they break down, they give out energy. We call those kind of atoms, at the bottom here mainly, but not always, radioactive. Radioactive atoms are those that give out energy when they break down. Thank you. Hope you enjoyed the video.